Hi, welcome to Unit 2 practice problems. In this video, we're going to go over derivative using definition, instantaneous rate of change, and derivative using quotient rule. So let's start with the first one. Derivative using definition. So you'll first need to know what the definition of a derivative is. I'm talking about the actual equation. So derivative of f of x equals limit h to 0 times f of x plus h minus f of x over h. And so in this equation, or in this problem, the first thing that we're going to do is plug in the f of x with this right here. So we would first do the derivative of f of x equals limit h approaching 0 to, and then we can put parentheses, the square root of 3x plus h minus 4 minus the square root of 3x minus 4. It's important to memorize the equation because it's going to show up on the AP exam if you're taking one. The next thing we need to do from here is actually multiply by the conjugate. And because we're multiplying by a conjugate, we'll be able to get rid of the square root. So f derivative of x equals limit h to 0, and then square root 3x plus h minus 4 minus square root of 3x minus 4 divided by h. And so to multiply by the conjugate is basically like the difference of squares. So multiplying x minus y times x plus y would equal x squared minus y squared. And so we're trying to get to this x squared minus y squared, and so far this would be our x minus y. So that's why we want to multiply by x plus y. And obviously we can't just multiply the top part and forget about the bottom part. So both the denominator and numerator have to be multiplied by that form of x plus y. So 3x plus h minus 4 plus 3x minus 4 divided by the exact same thing. So it would basically be just multiplying by 1. And so to simplify that out, derivative of f of x equals limit h to 0. And so rather than multiplying this by this, this by this, this by this, and then this by this, we can simply just do what we saw before and square this number, and have the negative right there. So we would have 3x plus h minus 4 in parentheses. Parentheses are important because it makes sure that you distribute any negative signs like seen over there. Then on the bottom part, we can't forget to add on this. So I'll just copy it again. Cool. And so now we see the top part is super easy to just simplify out. So that's what we're going to do. So 3x plus 3h minus 4 minus 3x plus 4, because the negative distributes to both the negative, to the 3x and the negative 4 to get positive 4. And then from here we can see that we can cancel out this 3x minus 3x and this negative 4 plus 4. And that would leave us with 3h. But wait a minute, we can still cancel out this h and this h up here, because at that point it would just be 3h over h and some numbers. So in this case, we would be able to cross out the h's because there's no adding on the numerator side. So we would be left with f derivative of x equals limit h to 0, 3 on top, and then 3x plus h minus 4 plus 3x minus 4. And so at this point, we would be able to plug in the h to 0. So we would simply get equals, I'll do it over here, f derivative of x equals 3 over 3x. Remember, this is 0, so it would just be 0 minus 4 plus 3x minus 4. Well, wait a minute. These two are the exact same, so we can just do 2 3x minus 4 over or under 3. So this right here would be our answer to the derivative. Okay, now for the next problem. The next problem is asking about instantaneous rate of change, and specifically the average velocity and the instantaneous velocity. So the position function of a stone thrown from a bridge is given by s of t equals 10t minus 16t squared feet below the bridge after t seconds. So what is the average velocity of the stone between t equals 1 and t equals 5 seconds? So when it's talking about average velocity, we can go back to what we've learned in Algebra 2 or Pre-Cal, and it's basically just asking for the slope. So if it says you can use a calculator, then go ahead and use a calculator, but so the first position is 1. S of 1 equals 10 times 1 minus 16 times 1 equals 16 with 1 squared, which is still 1, equals negative 6. And then S of 5 equals 10 times 5 minus 16 times 5 squared equals 16 times 25, which is 25 quarters, 16, 400 minus 50. So that would be negative 350. And then to find the rate of change, basically the slope, so change of y over change of x. Y in our case, negative 350 and negative 6. So we can do negative 350 minus negative 6 over the x's, which is 5, 1, 5 minus 1. So 350 plus 6, or negative 360 plus 6 is negative 344 divided by, oops, that's supposed to be 1, divided by 4. So 344, 4, 8, 6, 86, negative 86. So the average rate, we can write it as the average velocity of the stone between t1 equals 1 and t2 equals 5 seconds is slowing down at 86 feet per second. So the slowing down says that it's basically decreasing, which makes up for the negative. The second one is talking about instantaneous velocity of the stone at t equals 1 second. So in that case, it's wanting to get the derivative value. So if you remember from the notes or something, this velocity equals the derivative of the position. So the position function is up here, s of t, and the velocity would be the derivative of the position. So in that case, we just need to find the derivative of s of t, and we can easily use chain rule for this. So if, here, let's rewrite it. If f of t equals 10t minus 16t squared, derivative of s of t equals 10 minus 32t, and then it wants t of 1 second, and so it says note that speed equals the absolute value of velocity. So basically, if we plug in 1, because it's asking for time of 1, we get 10 minus 32 times 1, which is just 22. In this case, negative 22. So we can write it as the instantaneous velocity of the stone at t equals 1 second is 22 feet per second. It says that speed is the absolute value of velocity. So let's move on to our last problem. Okay, the derivative of quotient rule. So if you remember from the slides, it says on the little cheat sheet that the derivative of using quotient rule is low d high minus high d low. Low times the derivative of high minus high times the derivative of low over low squared would give us our derivative. So we can start off by first defining the derivatives of both the numerator and the denominator. So we can randomly name them. So let's name the top, or the numerator, f of x. F of x equals 4x squared minus 7x. Then we can simply use chain rule. The derivative of f of x equals 8x minus 7. And then the bottom part, we can name g of x. So g of x equals 5x plus 3. The derivative of g of x is simply 5. And so to set up our derivative, we need the low, which is 5x plus 3. It's good to use parentheses so you can organize stuff, times the derivative of the high, which is 8x minus 7, minus the high, which is 4x squared minus 7x, times the derivative of the low, which is simply 5, and then divided by 5x plus 3 squared. But obviously you can simplify it out and then do distribution over here, and then make sure to add this negative and then simplify it out. So that's it for this video, and thank you for watching.